Hello. Recall that in the previous lecture we discussed a protocol for KDC mediated authentication which had some vulnerabilities. We now discuss improved protocols for KDC mediated authentication. So a secure protocol is Needham-Schroeder protocol. It improves upon the protocol that we discussed in the previous lecture. This protocol is shown in this figure. Here N1, N2 and N3 are nonces. In this scenario, this is a scenario where there is a KDC in a network and a user Alice wants to communicate with a user Bob. So this protocol operates as follows. First, Alice sends a message to the KDC saying that she wants to communicate with Bob, and Alice includes a nonce in this message N1. So as we'll see, this nonce is included so that some intruder 2D who has stolen an old key of Alice cannot use an old message sent from the KDC to Alice to communicate with Bob. So this nonce is included to check the freshness of this communication from Alice to Bob. So to start with, this Alice sends this message which includes a nonce N1 to the KDC. Then the KDC invents a key KAB which can be used for secure communication between Alice and Bob. And the KDC sends this message KAlice along with the nonce N1. The same nonce N1 is included in this message along with Bob. This is Bob's identifier. And this is KAB, that is the secret key that the KDC has invented, which Alice and Bob can use for securely communicating. And the KDC includes a ticket to Bob in the message. So ticket to Bob is KBob, KAB Alice, where this is Alice's identifier. This is the same shared secret key KAB, which can be used for communication between Alice and Bob. So notice that as before, the KDC does not have to initiate communication with Bob to share the key KAB with Bob. Instead, the KDC just provides a ticket in the message sent to Alice. Subsequently, Alice can contact Bob and share the ticket obtained from the KDC. In the third message, Alice sends the ticket obtained from the KDC to Bob and KAB N2, where N2 is another nonce. This KAB N2 is a challenge to Bob to check whether Bob indeed knows the secret KAB or not. Assuming that this message reaches Bob, that is the legitimate Bob, in that case Bob can use this ticket and decrypt it because Bob has the key KBob shared with the KDC. So Bob can decrypt this ticket and obtain KAB and Alice. So by checking this message KAB Alice, Bob can verify that the person who has contacted Bob is indeed Alice. Now Bob has obtained the key KAB. Bob can decrypt this message KAB N2 to obtain the nonce N2, and then Bob decrements the nonce N2 to get N2 minus 1 and generates another nonce N3, which is a challenge to Alice, and appends N2 minus 1 and N3, and the result is encrypted using KAB and sent to Alice. Now Bob has sent a challenge N3 to Alice to check whether Alice knows the key KAB. Now Alice decrypts this message and checks whether the first part of the message N2 minus 1 equals the nonce that she sent minus 1. If yes, then she is convinced that Bob knows the secret KAB. Now the second part of the message is a nonce N3, which is a challenge to Alice. Alice decrements that by 1 to get N3 minus 1 and then encrypts the result using KAB to get KAB N3 minus 1 and sends it to Bob. Bob decrypts it and finds out N3 minus 1 and checks whether that equals the nonce that is sent to Alice minus 1. If so, then Bob knows that Alice knows the secret KAB. So at this point, KDC mediated authentication has been done. So in particular, Alice and Bob have agreed upon a secret key KAB, which they can use for communication, as well as they have mutually authenticated. So the Needham-Schroeder protocol not only allows Alice and Bob to agree on a secret shared key KAB, but it also allows them to subsequently mutually authenticate. Let's now analyze this protocol. Why is the nonce N1 used? So it is used to protect against the following threat. Suppose 2D stole an old key of Bob, let's call it K Bob old. Then Bob changed his key to K Bob. Bob may have suspected that his old key is stolen, so Bob changed his key from K Bob old to K Bob. Also 2D recorded message 2 when Alice earlier contacted the KDC for getting the shared key with Bob. Now 2D waits for Alice to contact the KDC and then 2D replace the recorded message 2. So 2D impersonates the KDC's network address and waits for Alice to contact the KDC. So the connection of Alice to the KDC actually goes to 2D, and then 2D replaces the recorded message 2 and then impersonates herself as Bob to Alice. This is done as follows. When 2D sends this old recorded message 2 to Alice, Alice then extracts the ticket from it. So notice that this ticket is encrypted with Alice's key, so 2D cannot directly obtain the ticket. But when this message reaches Alice, Alice decrypts this message and obtains the ticket, and then Alice initiates a communication with Bob. Now 2D intercepts that communication as well. 2D impersonates Bob's network address. So this message reaches 2D. Now 2D has obtained the ticket. Notice that this old message 2 was sent when Bob's key was K Bob old. So the ticket is K Bob old KB Alice. So 2D is able to decrypt this message using the old key of Bob, that is K Bob old, and obtain the secret KB from this ticket. So from this ticket, 2D is able to obtain the secret key KB, and then 2D has impersonated herself as Bob to Alice. Subsequently, 2D can start a communication with Bob pretending to be Alice. So 2D can also communicate with Alice pretending to be Bob. So this is a vulnerability against which the nonce N1 defends. So it defends against this attack that is possible in the absence of this nonce. So since this nonce N1 is sent, this nonce is included in the in this message 2 by the KDC. So this attack fails because in this attack 2D replayed the old message 2, but looking at the nonce in the message, Alice will come to know that it's a recorded old message. So this nonce must be the same as the nonce that Alice sent to the KDC for this message to be accepted by Alice. So hence this nonce N1 defends against vulnerabilities such as these. Now why is this string Bob included in this message 2? That is done to protect against the following threat. Suppose 2D intercepts this first message N1 comma Alice wants Bob and modifies the identifier Bob to 2D in this message 1. So the message reads N1 comma Alice wants 2D. So the KDC generates a key that is to be used for communication between Alice and 2D. So 2D obtains that message and is able to obtain the key, say K80, which is a shared key between Alice and 2D. And then 2D passes on the message to Alice, and Alice is tricked into talking to 2D, thinking that she is talking to Bob. So this is one attack that is possible, and that is possible because this identifier is not included in this message 2. So for defending against such an attack, this string Bob is included in this message 2. So when Alice receives this message 2, after decrypting this message, Alice can check that this key KAB, which is passed on by the KDC, is indeed meant for communication with Bob and not with someone else. So this string Bob assures Alice that this key KAB is meant for communication with Bob. So that's the reason for including this string Bob in this message 2. Uh, Note that the Needham-Stoddard protocol has been criticized for unnecessarily doubly encrypting the ticket to Bob. So this ticket to Bob is encrypted using KAlice, but the ticket itself is already encrypted using KBob. So it is encrypted first using Bob's secret key KBob, and then using Alice's secret KAlice. There is no loss in security if the ticket to Bob is sent from the KDC to Alice without encrypting with KAlice. Notice that anyway the ticket is going to be sent after Alice has decrypted it. So in this message 3, the ticket is anyway sent after Alice decrypted the message. So hence there is no need for encryption using KAlice in this message 2. That adds some overhead, and there is no loss in security if this ticket were to be sent without any encryption with KAlice. Now, in message 3, Alice sends a challenge KBN2 to Bob. Then Bob decrypts this message KBN2 to get N2, and then decrements it to get N2 minus 1, and then re-encrypts it to get KB N2 minus 1, comma N3. So this response KB N2 minus 1 proves that Bob knows the secret KB. In message 4, Bob also sends his own challenge KB N3 to Alice. Alice decrypts this message to get N2 minus 1 as well as N3, and then decrements N3 to get N3 minus 1, and then encrypts it using the key KAB and sends it to Bob. This proves that Alice knows KAB. So in these protocols, notice that the response to the challenge KABN is KABN minus 1. An alternative is the response could have been just N. So suppose Alice were to send KABN2 to Bob, and then Bob just sent N2 minus 1 along with KABN3. Then that would have served the purpose as well. So that demonstrates that Bob knows the secret KAB. So because Bob is able to decrypt KABN2 to get N2, so the response to KABN could have been N itself. So this is a variant in which a different kind of response is used to this challenge. Now there is one attack possible on this protocol if this KB N2 minus 1 comma N3 is of a certain form. Specifically, suppose a block cipher with electronic codebook is used to send message 4 such that it is of this form KB N2 minus 1 comma KB N3. So this message can be separated out into its components KB N2 minus 1 comma KB N3. So this would be the case, for example, when a block cipher is used to encrypt these messages N2 minus 1 and N3. We discussed electronic codebook in an earlier class. So suppose electronic codebook is used and the block cipher has k bits, and N2 minus 1 has k bits and N3 also has k bits. So electronic codebook separately encrypts the different blocks. So it would encrypt N2 minus 1 separately and N3 separately using the key KAB. So the message would be of this form. It would be separable into KAB N2 minus 1 and KAB N3. Then an intruder 2D can launch the following attack. This attack is an instance of the reflection attack that we discussed earlier. When Bob sends a challenge to Alice, Alice opens a new connection and obtains the response to the challenge from Bob himself. So specifically, first 2D eavesdrop on the authentication exchange between Alice and Bob, and then records this message 3. Later on, she sends the recorded message 3 to Bob. So the message sent is ticket comma KB N2. Now Bob responds with KB N2 minus 1 comma KB N4, where N4 is a nonce different from N3. Now 2D needs to send KB N4 minus 1. So 2D needs to find KB N4 minus 1. But 2D cannot compute KB N4 minus 1 because she does not know the secret key KAB. To obtain this KB N4 minus 1, she opens a new connection to Bob and sends KB N4. So 2D opens another connection with Bob and sends ticket comma KB N4 to Bob, and then Bob includes the response KB N4 minus 1 in this message sent to 2D. and then when Bob responds with KAB N4 minus 1 comma KAB N5, 2D has got the necessary information to respond to the first connection. So Bob responds with KAB N4 minus 1 comma KAB N5, and 2D uses KAB N4 minus 1 to complete the first authentication exchange. So this is an instance of the reflection attack, as we mentioned earlier. So for this reason, this message KAB N2 minus 1 comma N3 should not be separable into its components. So it should not be of the form KAB N2 minus 1 comma KAB N3. So to defend against this attack, this message 4 should be encrypted in such a manner that KAB N2 minus 1 cannot be reduced from KAB N2 minus 1 comma N3 if KAB is unknown. One simple example in which this can be done is, suppose N2 minus 1 comma N3 is of k bits, where the block cipher encrypts blocks of k bits each. So in that case, the entire message N2 minus 1 comma N3 is encrypted in one go by the block cipher. So KAB N2 minus 1 cannot be extracted from KAB N2 minus 1 comma N3. So this defends against this attack. Now there is a vulnerability in the Needham-Schroeder protocol that is shown in this figure. Suppose initially Alice's key is JAlice. When Alice contacts the KDC for a ticket to talk to Bob, an intruder, say 2D, records messages 1 and 2 of the exchange, and also assume that in message 2, JAB was the shared key generated by the KDC. So Alice sent N1 comma Alice wants Bob, and then the KDC sent JAlice N1 comma Bob comma JAB ticket to Bob, where ticket to Bob is KBob JAB comma Alice. Later 2D finds out the old key of Alice, that is JAlice, and uses it to find JAB. Notice that 2D has recorded this message 2, which was encrypted using JAlice. So since 2D has found out JAlice, she is able to decrypt this message and obtain the old key JAB. Now Alice suspects that her key has been stolen and hence changes her key to KAlice. So KAlice is the new key of Alice. But even after Alice changes her key, the protocol is still not secure, because 2D can still use the old key JAB and the old ticket KBob JAB Alice to impersonate herself as Alice to Bob. So since 2D has recorded the old messages that were sent using the key JAlice and JAB, 2D can just initiate a connection sending message 3 to Bob. It contains the message ticket comma JAB of N2, since 2D knows JAB. So 2D can send ticket comma JAB N2, where the ticket is KBob JAB of Alice, and then subsequently 2D can start communicating with Bob, pretending to be Alice. So to defend against this vulnerability, there must be some way for Bob to check whether this is a fresh connection by Alice or it is based on replays from a previous exchange with the KDC. So to defend against this vulnerability, there are two additional messages used at the beginning of the protocol, in which Alice asks for a nonce from Bob and Bob sends a nonce to Alice. So at the beginning of this protocol, we add some messages. We add two messages in which Alice will ask for a nonce from Bob and Bob sends a nonce to Alice, and this nonce is used to defend against this attack. That is, it is used by Bob to check whether this is a new connection from Alice or it is based on some old messages which use some old insecure key. The resulting protocol with these two messages added is called the expanded Needham-Schroeder protocol. So this expanded Needham-Schroeder protocol is shown in this figure. So it's very similar to the previous protocol, except that two messages are added at the beginning. So now there are 7 messages in this protocol. First, Alice sends a message to Bob initiating the communication, saying that I want to talk to you. So Alice wants to talk to Bob. Then Bob sends a nonce to Alice encrypted with his secret key, KBob. So Bob sends the message kbob nb to Alice, and this nonce has to be included in the message sent from Alice to the KDC. And then the KDC includes this nonce NB in the message that that the KDC sends to Alice. So the KDC includes this nonce NB in the ticket to Bob. So now the ticket to Bob contains the nonce NB. So when the ticket is sent subsequently from Alice to Bob, Bob is able to decrypt the ticket using his secret key kbob shared with the KDC. And is able to check whether this nonce NB is the same as the nonce that he had sent to Alice. If yes, then Bob knows that this message corresponds to this initiation of communication from Alice to Bob. So Bob knows that if this nonce NB is the same as the one in this ticket, then this connection is legitimate. If this nonce does not match this nonce that was sent from Bob, then Bob knows that something is wrong. It may have been an old message that is replayed. So in this message to Bob sends kbob nb, where nb is a nonce generated by Bob. Then the KDC includes nb in the ticket to Bob. So as we have seen here, nb is included in the ticket to Bob. So the vulnerability that we discussed on the previous slide is fixed because old recorded exchanges of Alice with the KDC will not enable 2D to authenticate as Alice to Bob, because the nonce in the old ticket will not match the new nonce that is sent by Bob. So after Alice changes her key to kAlice, the KDC knows that her key is now kAlice. So 2D will also not be able to talk to the KDC using the old key jAlice. So for these reasons, the vulnerability that we discussed on the previous slide is fixed, and this is a secure protocol which overcomes the vulnerability in the original Needham-Schroeder protocol. So using a nonce NB, this expanded Needham-Schroeder protocol overcomes the previous vulnerability. In summary, we discussed protocols for KDC mediated authentication. We discussed Needham-Schroeder protocol, and then there was a vulnerability in it which was overcome by the expanded Needham-Schroeder protocol. This concludes our discussion of authentication. Thank you.